Hey, math students. We are continuing our discussion here of the sum of digits divisibility tricks, I should say. This is the third video out of 3. So if you didn't take a look at the trick for 3's and the trick for 9's, I would check those out first. Or at least make sure I have some background knowledge of that. But what I want to point out to you is 6 is a composite number. What do I mean by that? What do I mean by a number being a composite number? As it turns out, what a number is made of or composed of affects a lot of divisibility principles and so many different concepts in math. So 6 is a composite number, meaning that I can multiply to make 6. Now you might be thinking, of course I can multiply to make 6. I can multiply 1 times 6. But I didn't make 6 there. The 6 was already there. I mean that I can take other numbers besides 6 and multiply to make 6. Let me show you what I mean there. Instead of doing 1 times 6, there's other ways to multiply to make 6. Like you could take the numbers 2 and the numbers 3 multiplied together to make 6. So 6 is composed of 2 times 3. It's a composite of prime numbers. Prime numbers are put together, multiplied together to make composite numbers. Okay, so that means if 6 is composed of both 2 and 3, then every number on the 6 times tables will behave like the 2 times tables and the 3 times tables. Because it's on, sorry, I'm having all kinds of technical difficulties on this video. It's on the 2 times tables and it's on the 3 times tables. Okay, so super good news because we already know the rule for 2's. Remember the divisibility trick for 2's is one of those final digit tricks. We learned basically that all even numbers are divisible by 2. Even numbers are divisible by 2. And we learned the divisibility trick for 3's in that first video I was talking about, the sum of digits video. If you add the digits together and the answer you get is divisible by 3, then the number itself is divisible by 3. So you know what I'm going to do if I want to check for 6's? I'm just going to check that both these things are true. Okay, let's take a look. Let's look at our 6 times tables first of all to examine the ones we know to make sure that these two rules are at least true of the ones we know. So let's try to count by 6 for a while. 6, 12, and again, I'm just counting. I could just, if I didn't know the next one, I could just count it by 6. So 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I'm counting on my fingers, y'all. 25, 26, 27, 28, 29, 30. I know some of you guys are like scared to count on your fingers. Some grandma or old math teacher scolded you for it, told you we're cheating. It is not cheating to count on your fingers. It is not cheating to use the tools that you've been given in order to figure things out in math class. That's the mark of a mathematician, someone who can figure things out. Okay, so that being said, I've got a list of the 6 times tables up for a while, and let us check that they are all even. Take a look. Ends in a 6, ends in a 2, 8, 4, 0, 6, 2, 8, 4, 0, 6, 2, 8, 4, 0. Are all these numbers even? Yes, they are. Next thing I see is that a sum of digits for 3. So the sum of digits is divisible by 3 because I'm checking for 3's. Not by 6 necessarily, but by 3. So 6 is just one digit. 12 is 2 digits, 1 plus 2, and if I'd add them up, I'd get 3. 18 is 2 digits. If I add them up, I'd get 9. 24, same thing. 2 plus 4 would give me 6. If I add up the individual digits here, I always get something on the 3 times tables. So what I'm seeing here is that all these numbers on the 6 times tables obey the divisibility rules for both the 3's and the 2's, meaning they're divisible by both 3 and 2. Of course, because they're composite numbers. And I could keep going, but I think that you see my point. Every single number I got is on the 3 times tables. So the sum of digits of something on the 6 times tables will be divisible by 3, plus it'll be an even number. We need it to pass 2 tests. So let's go and take a look. So is 540... sorry, I'm trying to come up with a good number. Let's do 549 divisible by 6. Now remember, it has to pass both tests. It has to pass the test for the 2's and the test for the 3's. And although this number would pass the test for the 3's, if I added up 5 plus 4 plus 9, I'd get 18, which is on the 3 times tables. It doesn't pass the test for the 2's because the test for the 2's is it even? This is not an even number. It ends in 9. If it doesn't pass both tests, the answer is no, it's not divisible by 6. Let's look at one more example. Is, let's see, 483 a multiple, oh, wrong one. That's not what I wanted to do. Sorry. Let's do 384 a multiple of 6. Well, this one does pass the 2 test. It is even. First test passed. It also must pass the 3 divisibility test for 3's. So let me add up these digits. 3 plus 8 is 11, 12, 13, 14, 15. I get 15. Is 15 on the 3 times tables? Check. It sure is. So guess what? This passed the divisibility test for 2's and for 3's. Is 384 a multiple of 6? Why, yes, it sure is. Again, the divisibility tricks, one super useful way to use these tricks, I should say, is to reduce fractions. So sometimes students will get these giant fractions that they are not sure how to reduce them. 72 and 84, by the way. But what I notice about 72 and 84 is they're both even. Check. And their sum of digits, the numbers I get are on the 3 times tables. 7 plus 2 is equal to 9. That's on the 3 times tables. 8 plus 4 is equal to 12. That's on the 3 times tables. So we had a little sum of digits check on it. So since they're divisible by both 2 and 3, that means that I could take a 6 out right away. I'm going to take that 6 out of both of those numbers. Let's do it. 6 goes into 7 once. Remainder 1, 6 goes into 12 twice. And if you're not quite sure what kind of ninja division I'm doing, you should check out the division video. 6 goes into 8 once, remainder 2, 6 goes into 24 4 times. And I've just reduced this fraction pretty quickly. Now these two numbers still do have something in common that I didn't notice. An additional 2, I'd have to continue to divide, but I got that 6 out right away. Awesome. So if you have any questions about this or any other math concept, be sure to drop it in the comments and I will do my best to answer it.